All right, welcome back to part two. Um, of, we've accompanied the slideshow with this video, so hopefully you're taking notes as you go along. If not, feel free to go back and do so. Where we left off was with the period and graphing, so we're going to continue with that. Um, so our next thing we want to be able to do is look at a function and determine what parts of that function mean. So in this case, I have f of t equals 3 times the sine of 2t plus 1. And I am asked to determine the midline, amplitude, and period. So it's getting comfortable in recognizing what pieces go where in the equation. So this first 3 we said was our amplitude. Whatever is after the sine, addition or subtraction is our vertical shift or our midline. So that takes care of the amplitude and the midline. The period is gain from the equation 2 pi over b. B in this case is this 2. So I have 2 pi over 2, which when simplified is pi. So that's where the period is coming from. And we're going to do a couple more examples with those coming up before the end of the video. The last thing we want to look at is the horizontal shift. So in this general equation of a function, the h represents your horizontal shift. And you need to keep in mind that the h is isolated from the subtraction sign. So if it was, for instance, t minus 4, my h value is 4, so I'm going to go 4 places to the right. If I have t plus 4, my h value is negative 4 because negative negative makes that positive. So I'm going to go 4 places left. Remember, that's that counterintuitive thing. When you see the negative, it's the kind of the opposite direction because it's based on what h is, not what the subtraction of h is. So let's take a look at an example. And this is one you'll come across quite a bit and is often one of the main causes of errors when we're working with sinusoidal functions. So we want to sketch a graph of 3 times the sine of pi over 4t minus pi over 4. Well, in order to do that, I need to make sure that I am in the form in this case it's sine and I'll just use their variable t. So I have my amplitude, my b value, my h value, and my k value. The key part to figure out and recognize is what is here after the sine. So I am not right now in that current form of b times t minus h. So I have to factor the function. The greatest common factor of both of those is pi over 4. So when I factor out pi over 4, I'm left with the t minus 1. Now I have a b value of pi over 4 and an h value of 1, and now I can work with and sketch a graph. So it'll have the same shape as the sine function. The midline will be the same because there's no k value. The amplitude is 3, which means its peak is 3 and its trough is -3. The period is 2 pi divided by b. And now that I have a b of pi over 4, I get a period of 8. And I have a horizontal shift of 1 to the right. So instead of starting at 0, 0, this graph is going to start at 1, 0. Because I know the period is 8, I know it's going to end at 9, 0. And now I'm thinking about my 4 quadrants. Halfway through on a sine curve, it's going to cross the x-axis. So halfway between 1 and 9 is 5. So halfway between my first 2 points is where it's going to be a peak. So between 1 and 5, that would be 3. And I know my amplitude says 3. And then the second part, halfway between 5 and 9 is 7. That's going to be my trough. My trough based on my amplitude is going to be -3. So now I can sketch this sine curve. And because it's repetitive, it's going to continue going on and on in both directions. So if you're just asked to sketch the one sine curve, one full rotation, you would do it from 1 to 9. So now I'm going to go the other way. I'm going to figure out the equation based on the graph. So I'm looking at this curve, and to me, I see a cosine curve between 1 and 7. And I'll do this one out 2 different ways. So I know my period between 1 and 7 is going to be 6. My midline, or my graph goes from +1 down to -5, which is 6. So my midline is going to be right halfway between at -2. So midline is at x equals -2. Based on my midline, the distance to the bottom or to the top is my amplitude. That gives me an amplitude of 3. And my cosine curve, instead of starting on the y-axis, starts at 1. So I have a horizontal shift of right 1. This gives me all the information I need to write an equation. So because I'm doing a cosine curve, I have my amplitude first, which is 3 times the cosine. To find my b value, I need to use my period. So if period is 2 pi over 6, sorry, 2 pi over b, I can replace 6 with period. Multiply both sides by b, divide both sides by 6, as they've done here. And then simplified 2 over 6 to 1/3. So my b value is pi over 3. I'm going to go X. I have a horizontal shift of 1 to the right and a vertical shift down 2. So down 2 would be subtract 2, which is this equation right here. However, there are multiple options you can have. If I go back to my original graph, I'll just indicate some of them and we'll delve into them a little later. I have, starting at -2 to +4, an inverted cosine curve. In other words, been reflected over the x-axis. So instead of it starting at 1 on the y-axis, it's starting at -2. So it's had a horizontal shift of 2. It's negative out front because it's been reflected. The amplitude stays the same. My midline stays the same. And my period stays the same. From -2 to 4 is still 6. So this is my second cosine equation that would also work. In addition, I know we're getting crazy now. I could ignore cosine altogether if this question did not ask specifically for cosine or sine. I have a sine curve with my midline at -2, going from here up, down, up. So this red curve is a sine curve. So I could write the equation for the sine curve. So cosine and sine are essentially the same thing. They just have a horizontal shift applied to them. If I move the cosine back pi/4, I'm going to have an equivalent of a sine curve. If I move the sine curve forward pi/4 units, I'm going to have the same as a cosine curve. So they are interchangeable as long as we account for that phase shift. So putting this all together, both sine and cosine are periodic functions. They are both considered sinusoidal graphs. Their transformations are made up of a, b, h, and k, just like every other transformation we've done. A is referred to as the amplitude, and that's our vertical stretch or shrink. B is our horizontal stretch or shrink. H is our horizontal shift left or right. And K is our vertical shift up or down. If A is negative, it means it's been reflected over the x-axis. If B is negative, it's been reflected over the y-axis. And we find our period by doing 2 pi over b, or we can find our b value by doing 2 pi divided by the period. Let's just put that in there. Where p is period. So that wraps up our introduction. I know it was a lot, 2 videos, but that's all we're doing this week. We're going to cut back from the work. You're going to have 6 problems to do for work, and I'm going to do 4 practice problems with you now. But what we want to take away from this lesson are the periodic functions, They are sine and cosine functions from the unit circle. Remember, our domain is negative infinity to positive infinity. Our range of the basic sine and cosine is going to be -1 to +1. They're also called sinusoidal functions. And their transformations consist of amplitude, midline, period, and horizontal shifts. So we have some new vocabulary introduced in there. So I'm going to move the practice to a part 3, where I'll go over some example problems, and then that will wrap up with your practice problems to submit for week 3 of remote learning.